The purpose of this screencast is to demonstrate how to execute the Euclidean algorithm for finding the GCD of two numbers and then use the results to find the modular inverse of a value when appropriate. While most of this can be automated in Mathematica, our purpose here is to show the required steps and computations. To begin with, we will find the GCD of two reasonably large numbers, namely 1548 and 9877. The key to the Euclidean algorithm is to repeatedly use division with remainder. To do this, we will need to find the quotients. This can be easily done by using the numerical approximation command n. Our first step is to compute n of 9877 divided by 1548. That comes out to 6 and change, so the quotient is 6 by rounding down the result. To find the remainder, we're going to subtract 6 times our divisor to get a remainder of 589. You'll enter that into this table over here just to keep a nice record. All right, so we have a quotient of 6 and a remainder of 589. And now it's just a matter of repeating this. So we now divide 1548 by 589. So we're going to find the quotient when we divide 1548 by 589, and it's pretty much the same thing all over again. I take 1548, I divide it by 589, and I get 2 and change. I round that down, and then subtract it off. So I'm going to take 1548 minus 2 times 589, and I get a remainder of 370. All right, so my quotient was 2, my divisor in this step was 589, and I get a remainder of 370. And then that's the whole part of the algorithm. I just keep doing this. Now I'm going to take 589 and I'm going to divide it by 370. All right, so I take n of 589, divide by 370. That gets me a quotient of 1. And then I subtract off, and I get my remainder of 219. All right, so all this is we just keep doing this over and over. I'm going to divide remainder into remainder again. For the sake of expediency, we'll just now complete the remaining steps, and I'm not going to narrate them because that seems unnecessary at the moment. At this point, I'm going to speed it up a little bit. I know that 4 times 15 is going to be 60, so I'm not going to work that out, and that gets me a remainder of 8. And then I'm going to take 15 and divide it by 8. That goes in 1 time with a remainder of 7. And then I'm going to take 8, divide it by 7, which goes in 1 time with a remainder of 1. We've reached a remainder of 1, and since 1 divides everything, there's no need for the final step. I know that 1 is going to divide 8. So this tells us that the GCD of our two values is indeed 1. If we'd gotten something other than 1 and then got a remainder of 0, that would have been our GCD. Not the 0, but whatever we divided by. All right, well, since they're relatively prime, we can now use this to find the inverse of 1548 mod 9877. All right, so to do this, we're going to use a Euclidean table. All right, to construct our table, it's got 2 rows. The first 2 entries, the first row are blank, or more accurately not used. That's why they've been X'd out. The second row always starts 0 and 1. Our first step in completing the table is to fill in the first row, putting the quotients from the Euclidean algorithm into the cells, and we start with the last one. So we're going to start with 1, and then work our way up and then it's 1. All right, so just to double check, 1, 1, 4, 2, 1, 1, 1, 2, 6. Okay, so they've gone into our table in that order. All right, now we need to complete the second row. We complete the second row by using this formula here. I start with my quotient, I multiply it by the entry in the second row immediately to the left, and then add the entry to the left of that. So to get started, I will take 1, multiply it by 1, and add 0, which will be 1. And I'll take 1 times 1 plus 1, that will be 2. 4 times 2 plus 1, so that'll be 8 plus 1, that's 9. 2 times 9 is 18, plus 2, that gets me 20. 1 times 20 plus 9 is 29. Now the arithmetic is going to start to get a little trickier. So this will be 49. All right, 1 times 49 plus 29, 49 plus 29, it's going to be 78. All right, and again, I'm going to be lazy. 2 times 78 plus 49 is 205. Okay, and then 6 times 205 plus 78 is 1308. Okay, and so there is our completed Euclidean table. All right, now let's get these computations. The two values we're interested in are these last two. All right, I'm going to take the largest, and I'm going to multiply that by the number I am trying to invert, 1548. And then I'm going to take the second largest, and I'm going to multiply that by my modulus, which is 9877. Now, when I do this, if I've done everything right, I should get either +1 or -1. Okay, in this case, I get -1. So that means that 1308 isn't the inverse of 1548, but it's close. -1308 is the inverse. All right, now we're working mod 9877, so I'm going to reduce that mod 9877, and I get 8569. So if we've done this right, if I take 1548 and I multiply it by 8569 and I reduce that mod 9877, I get 1. All right, so that's how the Euclidean algorithm and the Euclidean table work in order to find the inverse of a number when it's relatively prime to the modulus.